Hey guys, welcome to 1.4. In 1.3, we went over polynomials. So we were introduced to polynomials, we added them, subtracted them, and multiplied them. Now we're going to go over factoring polynomials. Excuse me. So when we are talking about factoring, we want to start the factoring process by putting the polynomial in descending order. It also frequently makes sense to combine any like terms if we're simplifying a polynomial. In this lecture, I'm not going to combine like terms. There will be examples where we have like 30x squared plus 12x minus 25x minus 10 because we want to practice factor by grouping, but normally you can consider putting the polynomial in descending order and then looking at it to see if you want to combine like terms to further simplify it, okay? Then you're going to factor out any GCF. What is a GCF? It stands for greatest common denominator. The greatest common denominator means we want to look at all of the terms. Remember, term is just that whole thing between each of the plus signs, right? The coefficient, the variable, and the degree. That is one term, one term, one term. So for the greatest common factor, you want to look at each of the terms and say, is there a number that I can divide? Well, is there a term that I can divide each of these terms by, thus making each of the terms smaller, right? So here we see the number 27, we see the number 6, and we see the number 30. If I think about that, I'm thinking those are all multiples of 3, right? So I could probably divide out a 3 from 27, 6, and 30. I could also look at m to the power of 8 and m to the power of 5 and m to the power of 3 and think I can factor out an m to the power of 3, right? So that's what we mean by factoring by grouping. Or sorry, oh, I always say that wrong. Greatest common factor. That's what we mean, is we're taking out anything that is common to all three of them to make those numbers smaller, because the smaller the number is, usually the easier it is to continue factoring and working with, okay? So after you've factored out a greatest common factor, also, if the leading term is negative, you want to factor out a negative greatest common factor because it's easier when the leading coefficient is positive. That's not, let me check. I don't think that's going to come up today, but that's just in general. And then after you have done, you've put it in descending order and you've factored out the greatest common factor, you're going to either factor by grouping, factor by reverse FOIL or AC method, or any other equivalent technique such as the quadratic formula, if you like that one, okay? If it has two terms, you can see if it fits into the rule for the difference of two squares, the sum of two cubes, or the difference of two cubes, okay? Before factoring any polynomial, answer questions 1 through 5 to identify which factoring technique you should use, okay? So what we're going to do is we're going to read through these, but we're going to do them one at a time, and then I'm going to go through the polynomials 6 through 28, and we'll just practice each of these, okay? So we'll practice taking out a greatest common factor. We'll practice factoring by grouping. Then we'll practice the AC method. Then we'll practice difference of squares and difference of sums and difference of cubes, okay? But the rules for today are completely factor each polynomial. Use whatever skills you have from previous math classes, whatever you know, okay? These are just examples. So, number 1, which polynomials have a greatest common factor? I'm going to take a highlighter and highlight them GCF if they have a greatest common factor, just by eyeballing them, basically, okay? Let's start with number 6. 27, so first I look at the coefficients. 27, 6, and 30 are all divisible by 3, and they all have a variable, the same variable, so I know that that is factorable by greatest common factor. I can factor out at least the number 3, right? And at least m to the third. Let's look at the other ones. We have number 7, 35x cubed plus 83x squared plus 36x. I don't know about 83, right? That's a pretty big number. I can't off the top of my head think of any numbers that I can divide it by, but I see that all three have the variable x. So I'm going to say they have the greatest common factor of at least x. I can factor out at least x, okay? Number 8, 16y squared plus 72y minus 40. No common variable, but those are all even numbers. 16 is even, 72 is even, and 40 is even. So I can at least factor out a 2. Okay. Looking at number 9, m to the 12th minus z squared. Nothing I can do with that because those are two totally different variables. No way to factor that. Number 10, a cubed b cubed plus 343. That those two terms don't have anything in common. I am looking at them though and thinking, that's only a binomial, so that might be, and I see a cubed, so that might be sum of two cubes, but that's not what we're doing right now. 11, 15z squared plus 8z minus 16. As we don't have a common variable to those three. Are 15, 8, and 16 divisible by a number besides 1? They're not. So I'm going to say that that's not going to have a greatest common factor besides 1, which doesn't help us, right? Number 12 has 30x squared plus 12x plus minus 25x minus 10. I do not see a greatest common factor. Again, we talked about combining like terms, but for the purposes of practice, we're not going to combine like terms today, okay? Those would be eligible for combining like terms, though. Here, I just have a binomial. I have the variable a in the first term and the variable a in the second term, so I am going to say that that is factorable by a greatest common factor. Good. 14 is x squared minus x minus 42. They do not all have a variable, and there are no coefficients besides 1 in the first two terms, so that is not factorable by greatest common factor. Here we have xy minus 6yz plus 10x minus 60z. There's nothing that is common to all four of those terms, so that is not factorable by greatest common factor. X cubed minus 8, nothing in common between x cubed and negative 8. 6m to the 7th minus 18m to the 4th minus 20m squared. Those are all the coefficients are even, so I know I can at least divide it by 2, and they all have a variable, so I can take out m squared, right? Same here, I can take out p squared. Number 19, I cannot factor anything. I could almost factor, but then we have this 2 that doesn't have an x, so I can't factor anything out of there. 5t to the 5th minus 10t to the 4th plus minus 75t to the 3rd. I can definitely factor out a greatest common factor because all of those numbers are divisible by 5, and we can also take out a t to the 3rd. Good. 16 minus 49. Is there a number that you can divide 16 by and that you can divide 49 by? I don't think so. Because the only factors of 16 are 8, 2, and 4, and 49 is not an even number, so it's not going to be divisible by any of those. 22, x squared minus x minus 35. I can't divide anything out of that one. 23, x cubed plus 16x squared plus 64x. I can take out an x, right? Here, I cannot take anything out because 25 is not an even number, so there's no common factor between the numbers, and 25 doesn't have an x either. Here, I can factor out some x's and y's, right? There's an x and a y, x and a y, x and a y. No, no, no. Okay, so those are the ones that we can factor out a greatest common factor. Should we work on that? Let's work on greatest common factor first. Beginning with number 6. So number 6 was 27 m to the 8th plus 6m to the 5th plus 30m to the 3rd. Good. Now I want to think about what are the factors of each of those coefficients, right? So 27, I can factor into 1 and 27, but we're going to skip that one because that one, we can't divide by 1. That doesn't make our numbers any smaller. That would be a common factor for any polynomial, right? So 27 divided by 2, we can't do that because it's not an even number. 27 divided by 3 gives us 9. So we have the factors 3 and 9. Anything else? And to do that, I just go through and divide it on my calculator. 27 divided by 3, 27 divided by 4, 27 divided by 5. You can also just Google what are the factors of 27. That's not cheating. That's just using technology to your advantage, right? So for 27, I think we just got 3 and 9. For 6, we have the numbers 3 and 2. And for 30, you can list them all, or you can just say, well, the only common factor so far is 3. It would need to be common with all of them. So the only one I need to find is 3. Is 3 a factor of 30? Yes, because we can multiply 3 times 10, right? So our common factor is 30. You could keep going and say it's also 5 and 6, right? But that's irrelevant because we're looking for a common factor. So our common factor is 3. And then if you take it a step further and go, what about m to the 8th? M to the 8th is 8 m's. M to the 5th is 5 m's. And m to the 3rd is 3 m's, right? What can we factor out? What is common? 1, 2, 3 m's are common. So our common factor is 3m to the 3rd. Yeah? If I divide 27m to the 8th by 3m to the 3rd, what do I get? And you can write it out down here. 27m to the 8th divided by 3m to the 3rd. 6m to the 5th, also divided by 3m to the 3rd. 30m to the 3rd divided by 3m to the 3rd. 27 divided by 3 is 9. M to the 8th divided by m to the 3rd is m to the 5th. Why is that? Because of the rule, right? So in 1.3, we learned that x to the power of a times x to the power of b is equal to x to the power of a plus b. X to the power of a divided by x to the power of b is equal to x to the power of a minus b. That's the other rule, okay? That's the one we're applying right now. So a minus b in this case would be would be 8 minus 3, which would give us 5. Good? Or I knocked out 3 out of the 8. I have 5 left over. 6 divided by 3 is 2. M to the 5th divided by m to the 3rd. 5 minus 3 is 2, or there's 2 left. And 30 divided by 3 is 10. M to the 3rd divided by m to the 3rd doesn't leave me with any m's, so it's done. So that is the factored form of 27m to the 8th plus 6m to the 5th plus 30m to the 3rd. And m. Nope, no m's. Sorry. That was ridiculous. Moving on. Let's factor number 7. Number 7 is 35x to the 3rd plus 83x squared plus 36x. Good? All right, what are the factors? And I would, in this situation, honestly, I would just Google, are there any factors of 83? If it was during an exam and you couldn't Google that, you could go through 83 and just start dividing it by every number in your calculator if you wanted. I wouldn't even do that in an exam situation. I would say, what are the factors of 35 and 36? Do they have anything in common, right? So 35, the factors are 1 and 35, uh, 5 and 7, yeah. And then 36, there's a lot of them, but it's 5. Is 36 divisible by 5? No. Is 36 divisible by 7? No. So there's not going to be a common factor in terms of the coefficients. There's not going to be a number that you can divide 36 by and get a whole number, and 83 by and get a whole number, and 35 and get a whole number. So I'm just going to divide them by x. So that becomes 35x cubed plus 83x squared plus 36x. All of that divided by the greatest x we have, which is just 1x. And I get 35x squared plus 83x plus 36. And on the outside, I have x because that's what I factored out. Good. So that's factoring out the greatest common factor for number 7. So for number 7 so far, we have x times 35x squared plus 83x plus 36. Now, it is possible to continue factoring that, but right now I just want to focus on greatest common factor, okay? Number 8 is 16y squared plus 72y minus 40. So there is no variable that is common to all 3 of the terms, but we can factor out a number from the coefficient. So what are the factors? Start with the smallest number. What are the factors of 16? 1 and 16, 2 and 8, and 4 times 4 makes 16, right? Those are all the factors of 16. Now I can go to 40 because that's the next biggest one because 72 is really big, right? I don't need to find all the factors of 40, remember, because we're only finding those that are in common, right? So can I take 40 and divide it by 2? Yes. 40 divided by 2 is 20. Can I take 40 and divide it by 8? Yes. 40 divided by 8 is 5. And 40 divided by 4 is 10. So I'm only taking 2, 8, and 4. Now 72, because it has a ton of factors, but I don't want to do all of that listing, right? So can I take 72 and divide it by 2? Yes, I think it's 36. Can I take 72 and divide it by 8? Yes, it is 9. And can I take 72 and divide it by 4? Yes, it is 18. Good. We have a lot of common factors, right? We have 2, we have 8, and we have 4 common to all 3 of them. Which one should I pick? I should pick the greatest. So I'm going to pick 8 as my GCF and no variable, okay? So rewrite it as 16y squared plus 72y minus 40. Divide each of those by the number 8. 16y squared divided by 8 is just 2y squared. 72y divided by 8 is 9y. And then negative 40 divided by 8 is negative 5. What do we do with that 8? We should put it in front. I kind of don't have room. So we have 8 times 2y squared plus 9y minus 5. You can continue factoring that one, but that is removing the greatest common factor, which is what we're practicing right now. Good? So for now, 8 has 8 times 2y squared plus 9y minus 5. Number 13 is 9a to the third minus 64a. Okay, what are the factors of 9? 9 is just going to be 3, right? 3, 9, and 1. Can I take 64 and divide it by 3? I don't think so, right? You can test it, but I don't think so. 64 divided by 3 is going to be 21.3. So there is no factor that is common to 9 and negative 64. So we're just going to factor out the a. So that will be 9a to the third minus 64a, both of them divided by a. 9a to the third divided by a is 9a squared, and negative 64a divided by a means negative 64. And what do I have to do to that a that I took out? I put it in front. Good. All right, let's look at number 17 for factoring. Greatest common factoring, because this is all factoring, right? So number 17 is 6m to the seventh minus 18m to the fourth minus 20m squared. All right, 6. 6 is 3 and 2, right? I can't divide 20 by 3. The only factors of 6 are 3 and 2. I can't do 3 because 20 doesn't divide by 3. So my greatest common factor is obviously 2, because those are the only two factors of 6. I can divide 6 by 2, I can divide 18 by 2, and I can divide 20 by 2. And then I can take out an m squared, right? So my factor is going to be 2m squared. We talked about taking out a negative greatest common factor, but that's only if your leading term is negative. So that becomes 6 divided by 2 is 3, m to the seventh divided by m to the 2 is m to the fifth, minus, keep that minus sign, 18 divided by 2 is 9, m to the fourth divided by m to the 2 is m squared, and then negative 20 divided by 2 is a negative 10, m squared divided by m squared gives you no m's. Good. So this one, we factored out 2m squared, and we were left with 3m to the fifth minus 9m squared minus 10. Number 18 is 49p to the fourth minus 28p to the third plus 4p squared. I don't think 49, 28, and 4 have any common factors, but we can take out a p2, right? So divide by p squared. That'll give you 49p squared minus 28p plus 4. Good. Oh, not 19, sorry. 19 is not factorable. 20, we have 5t to the fifth minus 10t to the fourth minus 75t to the third. I can factor out a 5, right? And what's the biggest degree of t that I can factor out? 3. 5 divided by 5 is just 1. T to the fifth divided by t squared cubed is t to the second. 10 divided by 5 is 2. And then 75 divided by 5 is 25. So that's my answer. 23 we have x cubed plus 16x squared plus 64x. All I can factor out is an x. X cubed divided by x is x squared. 16x plus 64. Good. And then 25 is our last one. That one's kind of creative. Oh, I'm losing my voice. All right, for 25, we have 72 x to the 8 y to the 7th plus 45 x cubed y to the 5th plus 63 x to the 6th y squared. Good. Look at each of the x's. What's the smallest x? X to the third. So I can factor out an x to the third. What's the smallest y? Y squared. Good. 72, 45, and 63. All right, if I start with, so I'm trying to determine what number I can divide 72, 45, and 63 by. I like to start with the smallest number, which in this case is 45, and list the factors, right? So what are the factors of 45? The factors of 45 would be 1 and 45, 3 and 5, and 9 and 15, right? Why did I list them like that? 3 times 15 is 45, and 5 times 9 is 45. So I didn't list them in their pairs, but it's still true. Okay, so can I take 45 and divide, oh, sorry, that was already 45. Can I take 63 and divide it by 15? I don't think so because that ends in 5 and that doesn't end in a 5 or a 0. Can I take 63 and divide it by 9? Let's find out, right? Or you already know. 63 divided by 9 is 7. So that one's okay. Can I take 63 and divide it by 5? I cannot. Can I take 63 and divide it by 3? I can. Good. All right, so now let's go over to 72. Can I take 72 and divide it by 9? I can. Good. And 9 is bigger than 3, so 9 is going to be the number that we're factoring out. 72 divided by 9 is 8. X to the 8th divided by x to the 3rd is x to the 5th. Y to the 7th divided by y to the squared is y to the 5th. 45 divided by 9 is 5. No x's because those canceled. And then y cubed. 63 divided by 9 is 7, we decided. X to the 3rd. So that's my final answer for 25. And remember, because I just almost forgot, put on the outside what you factored out. All right, so I have written down the greatest common factors that we factored out for all of the questions. Now we're going to look at point 2. If you have 4 terms, all right, we're going to look at part 2. We found all of the polynomials with greatest common factors, and we factored the greatest common factor out. Now we want to look at which polynomials use factor by grouping. And if we look up to step 2, it says if there are 4 terms in your polynomial, use factor by grouping to factor that polynomial. So we're going to write which type of polynomials use factor by grouping? It's polynomials with 4 terms. Something else to notice about them is so they have 4 terms. The first term will have a variable squared or an x squared. The middle terms will have the variable, and the last term will be constant. That is usually how we see it. Here, 8x to the fourth plus 20x squared minus 10x squared minus 25. This has x to the fourth, this has x squared, this has x squared, and this is a constant. But most of them that you're going to see, this one's different as well, but most of them that you will see in this course will look like this, where you'll have x squared, x, and then a constant. So let's start with, it doesn't look like any of, 7 doesn't have 4 terms, 8 doesn't have 4 terms, 9 doesn't, 10 doesn't, 11 doesn't. So we'll start with number 12, okay? 30x plus 12x minus 25x, or sorry, minus 10. Number 12. Factoring by grouping means it's similar to greatest common factor. With greatest common factor, we were finding a common denominator and taking that common denominator out of each of the 3 terms. Here we have 4 terms. We've established there is no common denominator. That's always true when you're factoring by grouping. There's no denominator common to all 4. So you're going to group them, factor by grouping. Okay? So group them into 2s. I just go like this. It doesn't matter the order. You could switch these 2 middle terms around. It doesn't matter. You're going to cover, well, I'm going to cover one of them because you've made a group, okay? Between 30x squared and positive 12x, can we think of anything we could factor out of 30x squared and 12x? I think we can factor out an x, right? And then 30 and 12, we can divide them. What are the factors of 12? The factors of 12 are 3, 4, 2, and 6, right? The biggest one of those being 6. I think we can factor 6 out of 30 as well. So we're going to factor 6x out of 30x squared plus 12x, just like we did with factor by grouping practice. Good? So that'll become 6x times the quantity. 30 divided by 6 is just 5. X squared divided by x gives me 1x. And then I keep that plus sign. 12 divided by 6 is 2, and x divided by x leaves us with no x's. All right, so that's the first half of our group. Second part of the group, negative 25x minus 10. It's very important, excuse me, if that term is a negative term, that the number that you factor out is a negative. So this was a positive 30x squared. We factored out a positive term. If your first term is a negative term, you want your factor that you factor out of both terms to be a negative. So negative 25 and negative 10, I think the greatest common factor would be a negative 5, right? And then there's only one x, so we can't add any x's. 25x divided by negative 5. A negative 25 divided by a negative 5 is a positive 5. X, negative 10 divided by negative 5 is a positive 2. Good, so that's exactly how I'm going to write it. I factored out a negative 5, so I wrote the negative right here, negative 5 times the quantity 5x plus 2. Now, we have, it looks really big, but all these are 2 terms. This is our first term. This is our second term. They're just being multiplied, right? 6x is being multiplied by all of this. Negative 5 is being multiplied by all of this. These are 2 terms. What we're going to do is we're going to take the greatest common factor out of those 2 terms. And what is that factor? It's this right here. Isn't that interesting? So we created the same exact binomial, and we're going to factor it out of both sides. So now we have 5x plus 2. And we factored it out of what's left here. Multiply it by 6x. What's left over here? Minus 5. So that's our final answer for number 12. We had 4 terms. We split them into 2 groups. We found the greatest common factor of each of the 2 groups, and then we factored out something common to the 2 greatest common factors and multiplied it by what was left, the 6x and the negative 5. So for number 12, our answer is 5x plus 2 times 6x minus 5. Good. All right. That's not 4 terms. That's not 4 terms. We'll try number 15 now. X, y minus 6y z plus 10x minus 60z. So two z's. All right. Here we want to factor by grouping because we have 4 terms. Good. I'm going to rewrite it because I didn't. It was kind of a confusing premise, and then I didn't write it clearly. When you're factoring by grouping, you can move the middle terms around if you want. So we have xy minus 6yz over here, and we have 10x minus 60z here. Now I'm thinking, okay, here I can factor out the y. Here I can factor out 10. If I flipped it, maybe I could factor out the x with the x and the 6, negative 6 with the negative 60. So it really doesn't matter. Okay, what we're going to do is, when I say it doesn't matter, it's because you'll get this same answer at the end, no matter which way you pair those two middle terms, whether you pair negative 6yz with xy or 10x with the xy, you'll get the same answer. All right, so for the first 2 terms, we have xy and negative 6yz. We're going to factor out only a y because that's all that was common to it. Our first term is positive, so it's a positive y. So I'm going to write it as y times the quantity xy divided by y. We are left with x. Negative 6yz. We're left with negative 6z. Good. Now, cover this side. We have a positive 10x minus 60z. Now, common factor to 10 and 60 would be 10, and then there's no variable that is common. Was that a plus sign or a minus sign? It was a plus sign, so it's going to be a positive 10. When I take 10x and divide it by 10, I'm left with x. When I take negative 60z and divide it by 10, I'm left with negative 6z. Good. So now these are my 2 terms. Luckily, this monomial is the same for both terms, so I can factor it out, and I will get x minus 6z times y plus 10. Good. That's my answer for 15. Which other one has 4 terms? I think there's only one left with 4 terms, and it's number 24. So number 24 is 8x to the 4th plus 20x squared minus 10x squared minus 25. All right, so we couldn't factor anything out of all 4 of them, so we're going to separate them into 2 groups. 8x to the 4th plus 20x squared. What's the greatest common factor for those two? I'm going to say x squared is certainly the greatest common factor for the variables. 8 and 12, you can divide them both by 4, right? You can divide them by 2, but you can also divide them by 4, and 4 is bigger, so that's one we're going to choose. Because we want the greatest common denominator. That will leave us with 4x squared on the outside. 8 divided by 4 is 2. X to the 4th divided by x squared gives me x squared. Positive 20 divided by 4 is a positive 5. X squared divided by x squared leaves me no x's. That's what I've got on that side. Now I'm going to look at the other side. Negative 10x squared and negative 25. That tells me immediately that I need to have a negative factor. All right. 10 and 25, the greatest factor is 5, and there's no variable over here, so I'm just going to say negative 5 is my factor. Negative 10x squared divided by negative 5 is just it's a positive 2x squared. Negative 25 divided by negative 5 is a positive 5. And so luckily we have the same binomial that is common to both terms. Go back and redo your work if you get this far and they don't precisely match. It just probably means you might have made a small mistake. So now I'm going to take that factor out, 2x squared plus 5, and I'm going to go ahead and factor 4x squared minus 5 as the other binomial. And we are done with number 24. All right, I've added those to our table. Let's go back and look at part 3. I might go from part 3, skip part 3, go before and 5, and then come back to 3. Okay. So it says which polynomials use the AC or reverse FOIL methods? Those are polynomials with 3 terms. Good. So if they have 3 terms, you use reverse FOIL or the AC method. I'm too zoomed in. I'm going to skip that. I'm going to go up to 4. Which polynomials are difference of squares if you have 2 terms? It could be difference of squares, or it could be the difference of cubes, or the sum of cubes. If you have 2 terms, we're talking about formulas that you can use to solve the problem kind of simply. You're not doing as much math, you're doing more labeling and filling in the blanks, okay? So let's talk about what the difference of squares formula is. This is how we write it. It is a squared minus b squared, because difference means minus. Squares means I have the square of a squared, b squared, the difference. Okay, that's how it gets its name. So the difference between b squared and a squared is equal to the quantity a plus b times the quantity a minus b. That's all it is, okay? For example, if we had x squared minus 4 equals, right? What you need to do here is you have a squared, you need to find a. You have b squared, you need to find b. We already know that that'll have a plus right here and a minus right here. That has a minus just because that's the type of equation it is, right? So in this case, if we had a squared and we took the square root of a squared, we would get a, right? Here we have x squared. And if I take the square root of x squared, I have x, right? So I just take the square root of the first term to get those two. Similarly, square root of b squared gives me b. So the square root of 4 gives me what to put right there. B squared, if I square it, right? B raised to the second power, but if I take the square root of it, I get the blanks for here and here. So if I just take the square root of 4, I get the number that goes right here, and you're done. So it's just fill in the blanks. The hardest part of difference of squares is identifying whether or not it's a perfect square. Okay, so let's look at our questions and see if we see any 2 terms, any binomials with perfect squares. For A and B. Well, you could better said binomials whose terms are perfect squares. Good? All right. Is m to the 12th a perfect square? This was not a good one to start on, but basically if you take the square root of m to the 12th, you get m to the 6th. So if I give you that piece of information, that might help. And if I take the square root of z squared, I get z, right? So this could be, or this would be a good use of the difference of squares formula. m to the 12 minus z squared is equal to m to the 6th plus z times m to the 6th minus z. Good, so you're just taking the square root of this one, putting it here, taking the square root of this one, putting it here. Let's see if we see any others. Those aren't squares, right? Those are cubes, so we'll come back to those later. That has 3 terms. Here we go. So not counting the a that we factored out, we have 9a squared minus 64. We want to take the square root of 9a squared. The square root of 9 is 3. The square root of a squared is a. And then the square root of 64 is actually 8. So we can write this as a, that original a, times 3a plus 8 times 3a minus 8. That's your difference of squares formula, right? So you have it, you take the square root of the first term, it goes right here. You take the square root of your second term, not counting the minus sign, take the square root of your second term, that goes right here. You're done. That a is just from the a that we had from factoring out the greatest common factor. Good. Any more 2's? That's x to the 3rd, so we cannot take the square root of it. Notice I could only take the square root of this because it was an even degree. So the even degrees you can take the square root of. The odd degrees, it will not come out as a non-decimal number, and it's a variable. Oops, forgot that in factoring by grouping. All right, 16x squared minus 49y squared. This is a good example. So we're just going to say, what is the square root of the first term? The square root of 16x squared. I know that the square root of 16 is 4. The square root of x squared is just x, because the square root is the opposite of taking something to the second power. And I'll look at that second term. I have 49. Remember, I'm ignoring the minus sign. I have 49y squared. The square root of 49 is 7, and then the square root of y squared is just y. So I take those and I put them into my formula, which is just a plus b times a minus b. My a is 4x. My b is 7y. 4x minus 7y is my final answer. Good. All right, any other ones? Oh, yes, this one is interesting. All right, so this is certainly not going to come up in our class, but it's interesting. If you have a fraction, you can still take the square root of both sides of the fraction. So the square root of 25 is 5, and the square root of 81 is 9. So if you have 25 81sts and you want to take the square root of it to find out if it's a perfect square, you just take the square root of each part. So the square root of 25 is 5, and the square root of 81 is 9. So my b is 5/9, and my a is obviously just x. So it'll be x plus 5/9 times the quantity x minus 5/9. Oops. Silly. I already whited that out. I can't put white out over white out. So that's what I would do for 27, even though it looked crazy. We do know that those are perfect squares. So we can, it is a fraction, and that's always panic inducing, but we just took the square of 2 numbers that we knew were perfect. Perfect squares. Took the square root of, excuse me. So that's how you do the difference of squares when you have binomials with terms being perfect squares, okay? Let's go to polynomials for the difference of cubes or the sum of cubes. What are those formulas and when do we use them? We use them with binomials with the terms being perfect cubes instead of squares. The formulas are a3, right? A to the 3rd power, a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. And then a cubed plus b cubed looks similar. Instead, it's a plus b times the quantity a squared minus ab plus b squared. Good. So this would be the difference of cubes because they're subtraction. This would be the sum of cubes. All right, so again, just like here, you're finding A and B and you're just putting them into the equation. The formula, excuse me. All right, so using that formula we just wrote down, let's see if we see any perfect cubes. Binomials with terms being perfect cubes. Binomial, that looks like a perfect cube. Is 343 a perfect cube? Do it however you would like. If you have that button, you can use that button on your calculator, or you can just say, what is this number? Oops, sorry, 4 to the third. What is that number cubed? 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 Until you get to the number or you get a number higher than that number, just to check. Good. So it looks like 343 is 7 cubed. A cubed, B cubed. What would we do here? A cubed, B cubed. Take the square root and we'll get AB. 343 we know to be 7. So now we know that A is the term AB and that B is the term 7, right? This is the plus. This has the plus sign. So we're going to copy A plus B. A squared minus AB plus B squared. So I'll just copy it right up there. My A is actually AB plus my B is 7. Here we have A squared. So that means I need to take AB and square it. You can either do it like that or you can do A squared B squared minus A, which again was AB, times B, which was 7, plus B squared, which is just 7 squared. And you could simplify that to, I don't have much room, so I'll just write it over here. I would simplify that to AB plus 7 times AB squared minus 7AB plus 49. Good. So that's the sum of two cubes. Here's the difference of two cubes. X cubed, we're going to take the cubed root. Sorry, that should have been the cubed root. I'm going to take the cubed root of x to the third, and we're going to get x. And if we take the cubed root of 8, we get 2. What that means is the equation is a minus b times a squared plus a times b. So I'm just going to write that as 2x plus b squared, which is 4 because 2 squared is 4. So that's the final answer for number 16. Good. Any others? No. All right, we can go back to this guy and do just a real quick factoring by grouping for x to the third plus 2x squared plus x plus 2. So I would look at those first two terms. X squared plus x cubed plus 2x squared. I can divide them both by x squared. X squared. X cubed divided by x squared gives me x. 2x squared divided by x squared gives me 2. Over here I have x plus 2. This is important because there's nothing to divide out, right? It's okay if you just divide out 1. That was a positive, so it's going to be a positive 1, and then you just write what you had, x plus 2. Good? All right, so our final answer is x plus 2 times x squared plus 1. Oh, sorry, couldn't even see that. Good? x plus 2 times x squared plus 1. So that one's for binomials with perfect cubes. Last one. If you have 3 terms in your polynomial, you want to use the AC method or the reverse FOIL method. All right, let's go all the way to the last page, 29, 30, and 32. Okay, and this will give examples of the reverse FOIL method. The first step of the reverse FOIL method is to list all possible factors of the first and last terms of the trinomial. So this is a trinomial because it has 3 terms. The first term is x squared. What are the all possible factors of x squared? It is just x times x. I guess you could say x squared times 1, but that never happens, so I'm not really going to worry about it. And then the last term of the trinomial is 12. What are the factors of 12? What are the factor pairs of 12? You could say 12 and 1, 6 and 2, 3 and 4. You would also say negative 12 and negative 1, negative 6 and negative 2, negative 3 and negative 4, right? So based on your knowledge of FOIL, which is that the first 2 terms, let's write out the factor, the binomial pair. So we need something here, something here, something here, and something here, right? Based on your knowledge of FOIL, these 2 numbers, or these 2 terms, when they're multiplied together, have to equal x squared. It's not going to be x squared times 1. That doesn't really come up in this class. So it's going to be, the only other option is x times x. Good? Now, first, outside, inside, last, the last term comes from these 2 numbers, right? That's why we made a list of the factors of 12. These 2 have to be the last 2 numbers. Or sorry, these 2 have to multiply together to become 12. Good? The other rule is that they have to add together to equal 8. I think it would be 6 and 2, right? And then when we use negative 6s or negative 2s, we would use positive negative 6 and negative 2, or positive 6 and positive 2. We would use positives because 6 and 2 become 8. Negative 6 and negative 2 would become negative 8. So the signs of the binomial factors are all positive. Number 31, sorry, number 30 says factor the trinomial completely if the polynomial cannot be factored right prime. All right, so we're going to write our factors of x squared and our factors of negative 99. X squared is just going to be x times x, right? Here's the reverse FOIL method. The factors of negative 99. I want to think about things that are going to multiply to negative 99, but they're also going to add to negative 2. So you could say negative 99 and 1, but that's 2. Those 2 are too far away, right? You could say negative 11 and positive 9, or you could say positive 11 and negative 9. Which of those do you think the difference would be equal to negative 2? This one, right? 9 minus 11 is negative 2. So we're going to say minus 11 plus 9. You can even work it back out if you would like, just to be sure. X times, FOIL it, x times x squared, x times 9 is 9x, negative 11 times x is negative 11x, negative 11 times 9 is negative 99. We'll add those together. X squared plus 9x minus 11x minus 99 becomes x squared minus 2x minus 99. Good? All right. Now, for the AC method, it comes from the first step used to factor a polynomial to form ax squared plus bx plus c. So from this information, we create a four-term polynomial. So the reverse FOIL method, you're listing out the factors and you're deciding where to put them. This works if a, right, ax squared, if a is 1, we use the reverse FOIL method. If a is not 1, if a is a number, you're going to use the AC method, and then you'll factor by grouping, okay? Step 1 of this process is we're going to do it with number 32, 7x squared plus 34x minus 5, okay? Multiply the first and last terms of the polynomial. So the product of the first and last terms, 7 times 5 is, 35. I generally just ignore the x squared because I put 1x in each binomial. So I just say 35. And then the sum, multiply the first and last terms, a and c. There's part a, there's c. We multiplied them, 7 times -5, oops, is -35. List all the factors of AC until you find the combo that yields the middle term of the trinomial. So the middle term of the trinomial is the b, right? 34x is our b. I'm going to put it right here. Sum means we need it to add. Yields the middle term of the trinomial. So we want it to multiply to -35 and we want it to add to 34. Good? All right, so let's list all of the factor pairs of -35. Okay. It's a positive 34, so I'm going to say -1, 35. I'm not going to say 1 and -35 because I know it needs to add to a positive number. And I think we found it, right? 35 minus 1 would be 34. We found it first try. Okay, so now what you want to do with these two terms whose product makes 7 times -5 and whose sum makes 34, b, you want to take them, keep a and c the same, and b becomes that. So instead of it being plus 34x, it's going to be plus 35x minus x. Good. Now we're going to factor by grouping that, which we've done several times today already. 7x squared plus 35x. Divide both of those by 7x. You get 7x times x plus 35. Nope, sorry. 35 divided by 7 is actually just, that's weird. All right, and then we have -x minus 5. So it's going to be a negative number we're dividing it by. We're just going to divide it by -1 because we can't think of anything else that goes. There's no other factors of x and -5. So -1, positive x, positive 5. And our final answer is x plus 5 times 7x minus 1. Good? All right, so that is the AC method. That is the reverse FOIL method. Those are the two methods we're going to use if it's a trinomial, which is what does come up a lot. Let's see if we see any good trinomials to just practice with, all right? Number 8, maybe? All right, number 8, let's do the AC method, okay? So the AC method is ax squared plus bx plus c. We want to make a table in which it should multiply to, so the product will equal A times C, and the sum will equal B. Okay, this is ax squared plus bx plus c. I'm gonna write down what number 8 actually is, which is 2y squared plus 9y minus 5. That's number 8, but we factored out the 8, okay? So this is after we remove the greatest common factor, we have this. And now we're going to further simplify that. Good. The product of A times C, the product of 2 times -5 is a -10, right? So we should need to find two numbers that multiply to -10 and two numbers that add to +9. We can say, so the product is negative, the sum is positive. So I'm going to say -1, +10, -2, +5. Both of those, so this pair multiplies to -10. This pair multiplies to -10. This pair adds 10 plus -1 adds up to 9. 5 plus -2 just adds up to 3. So this is the pair that we like. Okay? Now remember what we do with it. 9y becomes -1y, or you can just write -y, and positive 10y. So we use the AC method. That was A times C. Oh my gosh. I'm trying to make this less confusing. Stop it. A times C for the product. The sum is just B. 2 times -5 is -10. 9 is the sum. Listed all the factors of -10, figured out which one added to 9. Good. Once we found that pair, we replaced 9y with -1y and 10y. So we added y to it. This remains the same, 2y squared. This remains the same, -5. And then you're just going to factor by grouping. Ready? 2y squared minus 1y. We can divide them both by y. So I get y times the quantity 2y minus 1 over here. Positive 10y, so it's going to be a positive 5, right? I'm going to say plus 5. 10y divided by 5 is 2y. -5 divided by 5 is plus 1. Nope, sorry, it's minus 1. Which works out well because those two need to match anyway. So my final answer is 2y minus 1 times y plus 5 for 2y plus 9, 2y squared plus 9y minus 5. If you did the FOIL method back, you would get this answer back. And remember, we had that 8 outside of it, so our final answer would be 8 times the quantity 2y minus 1 times the quantity y plus 5. Good? All right. Any other ones that don't look terrible? Maybe 14. 14 has x squared minus x minus 42. Here we're going to do the reverse FOIL method. So you want to list all the factors of that one, which is just x times x, right? I don't like the reverse FOIL method. I'm just going to say this is the product of A times C. 1 and -42 is just -42. And then it needs to sum to equal -1. Because that's just a negative x. That's actually a -1. Good? All right, so what are the factors of -42? Again, feel free to just take Google and ask ChatGPT what the factors of -42 are, okay? Save yourself some time. We know we're looking for two numbers that are pretty close to each other because we want the difference between them to be 1. So I can say 42 divided by 8. 42 divided by 10. 42 divided by 6. Ooh, 6 and 7, right? That's good. 6. Maybe it's a -6 and a +7 because we need them to multiply to equal a negative. Or it could be +6 and -7. And we combine these, we get +1. If we combine these, we get -1. So we like this pair. That means x squared stays the same. Instead of -x, we're just going to put in plus 6x minus 7x minus 42. Good. Now we'll factor by grouping. X squared plus 6x. I can factor out an x, and I get x plus 6 times x. Here we have a negative sign, so I'm going to put a negative right here. 7x and 42, it's going to be a -7. So I'm left with x plus 6. So my final answer for number 14 is x plus 6 times x minus 7. Good? All right. What else? Number 22. Number 22, we have x squared minus x minus 35. So if a, we have a x squared plus b x plus c. If a is just 1 and it's just x squared, I know I can go straight to x times x. And I can kind of just think about it. So 35 is, oh, so this would be the reverse FOIL method. 35, -35 would be probably 5 and 7, right? But there's 2 between 5 and 7, right? We would need two numbers that are right next to each other to get that -1. So in fact, 22 is prime. So if you cannot solve it, if you put it into ChatGPT, well, I don't feel like ChatGPT would be good with math, but if you put it into some sort of math app and there is no way to simplify it further, you just say that this is prime. All right, so 22 is prime. And again, some of these you can continue factoring. I just didn't want to take up too much time. So 20 t squared minus 2t minus 25. How would we factor that? Same thing. Just imagine you're reverse foiling. I need two numbers that will multiply to -25 and that will add to -2. What do we think? 5 times 5. Won't work. Shoot, I'm just picking a bunch of prime ones. Hold on, guys. This is why. I made a mistake on number 20. 75 divided by 5 is 15. All right. Now it'll work. I wanted that one to work. All right. 15. What two numbers would multiply to -15 and add to -2? Well, a -5 and a +3, right? So you're done. That is factored. 20 also started with a 5t to the third. We factored that out earlier. So that's your final answer for number 20. Let's see. 23. 23 is kind of interesting. Right now we have x times x squared plus 16x plus 64. So for this, we know we just are going to have x and x. All of those are plus signs, so this is all going to be positive. We want two numbers that are going to multiply to 64 and that are going to add to 16. I'm going to just say it's 8 times 8, right? 8 times 8 is 64. 8 plus 8 is 16. And you can rewrite that as x plus 8 squared, if you would like. Let's do another. I don't want to do a huge one. 14. X squared. Where is the 14? All right, I guess I got to do the big ones now. 11. We have 15z squared plus 8z minus 16. Good? All right, so for the AC method, we need it to multiply to equal a times c, and we need it to add to equal b. A times c is 15 times 16. 240. And we need it to add to equal positive 8. 15 times negative 16 is negative 240. Good, so you're just going to make a really long list of the factors of 240, but you kind of want to make it some numbers that are close to each other, right? So 240 divided by 20 is 12. 20 times 12, maybe the 20 is negative and the 12 is positive. And that will give you a negative 8, but if we said the 20 is positive and the 12 is negative, that will give you a positive 8. Remember, that doesn't mean we put those there because this a is not 1, right? So we just keep 15, z squared, 8z becomes 20z minus 12z minus 16, and then we'll factor by grouping. 15z squared minus, plus 20z. Factor out a 5z. 5z times 3z plus 4. Over here, we've got negative 12z and negative 16, so it needs to be a negative, maybe 4. 12z divided by 4 is 3z, and negative 16 divided by negative 4 is a positive 4. So that final answer is 3z plus 4 times 5z minus 4. All right, guys, I feel like I have made this long enough. I've created enough examples. If you do still have questions, all you need to do is Google or YouTube, even better. There are really good YouTube creators out there for math. Any of the terms that you need to practice, and they will show you very engaging videos on how to work on that. But thank you guys so much and have a good one. See you next time.